Hi everyone, we continue on the lesson. We have topic 3 here, algebra and simple equations. In order to do complicated and to solve complicated equation, you need to start from easy one, and so we are going to work on easy ones here. Just we start from scratch to talk about algebra and how to solve equations. So before I start, we need to just see some words that we know them. So if we hear summation, it means addition. If we hear difference between, for example, two terms, difference between two variables, that means subtraction. Okay, that's subtraction. If we hear product, that's multiplication. So product of x and y, that's x multiple y. And if you hear coefficient, coefficient is the result of division. For example, what is coefficient of 6 and 2? So that's 6 divided by 2, and which is the result. The result of this quotient is 3, which is 6 divided by 2. Okay, so I just got help of some of these from another website. I didn't create them. So in order just to show you, see, if I have an equation, so I am in agreement, or I accept that the left side equal right side. Okay, in each side I have I have expression. Okay, so I have expression, so here I have expression here. Okay, each expression is made by numbers or variables, or number and variables, operators like additions, so subtraction, and those things. Okay, and I call each of them, which are separated by minus and plus, I call them I call them terms. Okay, so I have equation, which is here, one equation. This is one equation here. This is one equation, and I accept that this equation has expression here and expression here, and each expression is made by several terms, and these terms are separated from each other from plus and minus. Okay, so here it says expression is made by numbers, variables, operators, so all of them. Okay, so now term, a number or a variable, or a number and variable together are terms, and terms are separated by plus and minus. Okay, so for example, I can have a, x power b, y power c, z power d, or any other variables to different powers, and this can be just one term. I know here I just see for x, but that's possible to have one number multiple several variables to different powers. Okay, so again, the whole thing is an equation, and the equation has two expressions, so expression right, expression left, and each expression is made by several terms, and terms are separated with plus and minus. So here I have this as term, and this as term, and this as term. The term here can be just a number, or just a variable, or a number and variable in multiplication, like here. Okay, now I can show for each term. Look at this. For each term, if I have a number, I call it coefficient. Okay, so this is coefficient here. Coefficient. Okay, which is the next page. Okay, so this one here. The rest is variables. So variables to different powers. So here I just have one variable, but I can have more. Okay, so x, y, they are variables. The reason I call them variable is because they vary. Because it's x, and I can choose, or I can substitute, or I can find different values for x. Okay, so because it varies, so I call it variable. Okay. Also, I can have just a constant number. Look at 5, look at 7. They are just constant number because you don't see any variable beside them. But the number you see beside variable is not constant. I know it's constant because it doesn't change, but I call it coefficient. Minus here is operation, so operator. Okay, operator, operation number 1, subtraction, addition, those things. Okay, now constant is a fixed value which doesn't change. For example, 3. Variable is alphabetical character represent an unknown number because I don't know it. Because I don't know it, so it's variable. So x, y, so those. Coefficient is a number multiple which is not multiplied by variable, so which is this one. So coefficient here is this one. Okay. So equation, a statement that says two mathematical expressions are equal with each other. Okay, so when I see equal, okay, that's equation, right? And for each expression, I have several terms in addition and subtraction, okay? And for each term, I have just a number or variable or a number multiple variable, okay? So, of course, I'm not going to ask you what is the meaning of that, explain this, explain that, but you need to know them as we continue in algebra, you need to know this. Okay, so look at this example. Tell me how many terms you have. First of all, is it equation? No, I don't see any equal. So it's just expression. Okay, this expression, how many terms I have? Okay, so terms, I have 2x over y, I have 3y, I have xy over 2, and I have 5. These are terms. Okay, how about constant? Okay, so constant, which doesn't change, is 5. How about variable? Variables are x and y. Do I have any other variables? No. So I have to say x and y. How about coefficients? Okay, so coefficients are what? Coefficients are 2. Coefficients here is 3. And coefficients here is this one, which is, so 2 and 3 and minus 1 over 2, or just 1 over 2, just 1 over 2, because that the other one minus is just operation, okay, just subtraction. Okay, and operators are, these are operators, so plus and minus are operators. Okay, look at this. Many times I ask what is coefficient, or maybe a student, they find a question in Wiley Plus, they come and say the coefficient is 1 and 2. I say why? Because they see 1 at top and 2 in the bottom. No, coefficient is 1 over 2, half. Okay, so that's a good point here. Now I continue. Okay, now again, tell me terms. Okay, term, so I can write t here, term. 3x squared, 8, 5x, and 2 times y plus y squared. Okay, if you just try to simplify it, yes, you can have 2y plus 2y squared. For now, we don't know it, so we just write it this way. So what is separated by plus and minus? They are terms. Constant. Constant is 8. Coefficient 3, 3, 5, and 2. Variables x and y. Okay, so some more definitions. If I see just one expression with just one term, I call it monomial. If I see two terms, binomial. For example, here is 7x Here is 7x plus 4y. Here is 7x plus 4y plus, for example, 3. Here, this is trinomial when I have 3 terms. And if I have more than that, so I call it polynomial. Okay, so for example, it's like 7x plus 4y plus 3, for example, minus 2z. Okay, minus 2z, right? So this is polynomial because it has several. So monomial 1, binomial 2, trinomial 3. I call all of them polynomial. Okay, so just to make it easier. Also, there are some rules of sign. So some rules of distribution and some rules of commutative laws and those things. I want to again emphasize here. Okay? If I have two positive and two negative, the result is positive. Or I can say, if I have even number of negatives, because I don't know about A and B, maybe A and B are not positive, for example, here, okay? So, I can say even number of negative here, okay? Oops. Even number of negative. See, here 0 and here 2. So that's positive. If I have odd number of negative, that's negative. Why? Because I have here 0 negative, here 2 negative, here 1 negative, here 1 negative. And that's just negative, the result. Okay? But it depends on sign of A and B. Maybe sign of A and B are different, so that just change the result. Okay? How about distribution of a sign? Okay? See, I have a sign out of a bracket. Okay, so that's, for example, negative sign. Remember, you have to change sign of each term inside the bracket if you have a negative outside the bracket. Sometimes I see a student, they just change this one. So they have this, for example. They do minus a plus b minus c. That's wrong. If you have minus here, you have to do minus a minus b plus c. I mean, you have to change each term sign inside the bracket, all of them, because negative is outside the bracket. It is for all of them. Means you distribute negative to all of them. Commutative law. If I have a plus b, it's the same as b plus a. If I have a multiple b, is the same as b multiple a, but it doesn't work for subtraction. It doesn't work for division. No, it doesn't work. No, just multiplication and addition. Okay, so we need to know these things, and so because we use them, these are just basics and definitions and these things. Okay, simplifying. What do I mean by simplifying algebra? I have to simplify. How do I simplify? I have to simplify when I'm doing addition, when I'm doing multiplication, when I'm doing, so I see something large and I want to simplify it, okay? If you have addition and subtraction and you want to simplify, you have to collect like terms. By like terms, I mean when you have the same variable to the same power beside the coefficient in the term. Okay, you say two terms are the same if you have the same variable to the same power. Okay, for example, here these are like each other. If you do 2xy and 3xy, yes, they are like each other. Both of them x, both of them y, both of them to power 1. But if I have 2xy and I have 3x squared y squared, they are not like each other, although I have x and y in both of them. It must be to the same power. So When I give you a large expression, okay, so you see a large expression, and you want to just, and I tell you simplify it. Of course, you don't want to carry all of them. It's very time consuming. It's very likely you make a mistake. It's very likely you miss one of them, okay, and you get confused. So you have to simplify it. By simplification, I mean you have to look for terms which have exactly the same variables to the same power, and then add and subtract them. Okay? Sometimes we have to do more. Sometimes I have to do also multiplication and division and distribution and expand. I have to expand. Okay? We will see those examples. They can be more complicated. In this case, for simplification, I recommend you do many practice, many practice questions. You can't say you know it unless you do so many practice, because this can be very easy and this can be very hard if you see something complicated. So what is my method here? My method here is this. In this case, you don't see something very large, but if you see something large, it's very hard to keep track. So my recommendation is you start from beginning. What is the first one? What is the first variable and power? Okay, x squared. You underline x squared and then go to the end to find all of them with x squared. And you put the same symbol on there. Okay, this one, I'm done. Now I go to the next one. I do 2 lines here and I continue to find all of xy to the end. I'm done. Then I go to this one, 3 lines, because it's just y. When I am done and I see symbols under all of them, then I can say, okay, grouping is done. I group them. Now I add them. Now I simplify. Okay, equal. What is 3x squared plus 6x squared? I have 3 apple and 6 apple, so it's 9x squared. Now I cross them. If I don't cross them, if I don't make a symbol under them, if I don't group them, for sure I make a mistake. It's very likely I make a mistake. I miss one of them. I get confused, and it will be wrong. Okay, this is my recommendation. Start from beginning. Put symbol under them. Go to the end and find all of them. When you see symbols under all of them, you are done. Now collect them. Add like terms. Okay. 3xy minus 2xy. 3xy minus 2xy. Okay, 3 apple minus 2 apple. Okay, so 3 oranges minus 2 oranges. So it is plus xy. Okay, again I cross them. And the last one is this one, which is alone. So I write it here, minus 4y. Perfect. Instead of 5, I see 3 then. Okay. It can be very large. It can be very much larger than this, and you can simplify it. Maybe you have several of each, and you can add them, subtract them. This means simplification. How about here? Okay, again, as I said, you start from beginning. 4a. Do I see any a? I'm done. Next, this one and this one. Yes. Next, this one and this one. Done. Now I do equal. 4a is the first one. 5b squared plus 2b squared is 7b squared. Minus 3ab minus 5ba. Oh, I know ab and ba are the same. Okay, so I can do this. This and this the same, so it's minus 8ab. And the reason I group them because I know ab and ba are the same. Okay, so make sure to do many practice. I added many practice to the lesson and I just found them. Go to Google, find them. Go to Blackboard and go to practice part. I posted questions there. Make sure to do many questions. Simplification can be very easy, but can be hard if you have a larger expression, if you have many variables, different to different powers, maybe many terms. You can work on them, make it easier for yourself. How about multiplication of monomials? How about if we go to multiplication? Okay, multiplication, easy, easy. I multiply, I multiply number with number, this one with this one. Okay, so what do I mean here? Maybe I can make a formula. So it's X, B, Y, C, Z, D, for example, multiple W, X to, okay, so now maybe I do this, E, X, F, G, H. Okay, so you multiply A and E, you multiply X with X, Y with Y, Z with Z. For X, you have to do exponent rules. You have to put one X and add exponent. For Y, add exponent. For Z, add exponent. Okay, one by one. See, you do this one and this one, this one and this one, this one and this one, this one and this one. Okay, so here, what is the result? The result is 2 multiple 7, x 2 plus 1, which is, and I want equal for each line, it is 14x power 3. If I give this question, so for example, for the quiz and test, at the beginning when you see this question, maybe for the first quiz and test, you don't show me just the last answer, show me the reason. Okay, show me a step by step. But maybe in future, no, you don't need to really, you just can just find the answer, because for example, maybe the question is not about algebra. Okay, so at the beginning when we have specifically questions from this part, show me the reason and just the steps. Okay, so how about next? So minus 4 and this a power 2 plus 1 b power 1 plus 3, which is minus 12 a power this b power this. Okay, how about this? Dividing monomials. Dividing monomials, so the same. Okay, so I have a x power b y power c, for example. I don't make it more complicated. D x power e y power f. Okay, so you do a divided by d, x b minus e, y c minus f. One by one again. Okay, so you do this and that, this and that, and this and that. Okay, and for each one you have to use its own rule. So number and number, you just do division like fractions. Okay, and for x and y you do with exponent rules. Okay, so here is 20 divided by this, x 4 minus 2, y 3 minus 2, which is minus 4x power 2 y power 1. Done. Okay, how about this one? 6 divided by 2, x 2 minus 3, y 3 minus 2, which is, I need equal for each step, each line. Okay, which is 3 x this, y this. And for example, if I say I don't want to see with negative exponent, which one you touch? So which one you move? Do you touch 3? No. Do you touch y? No, but this one goes down because just the one with negative exponent is going to move. That's it. How about here? Okay, here I have x times this divided by that, right? Yes. So, can I cancel x and x? Yes, because it's multiplication and division. So, doesn't matter. I have a bracket. It's okay. That bracket is just one item. So, I can simplify. Or if I multiply x with the bracket, I can bring it out because it's inside each term. Okay? And I can cancel. So, it is 3 plus y. Okay? So how about this question? Okay, this question, so look at this. X squared plus xy divided by xy. Okay, can I cancel, can I factor anything from top? So I factor, what I can do, I can factor from top. What do I mean by factor? When you see something is common in each term, you can bring it out. What is common in each term? This is common. Oops. Wanted to change. Okay, so this is common and this is common. I bring it out. Okay, so it is x multiple x plus y divided by xy, which is, I can cancel, which is x plus y over y. Okay, and I want to emphasize this here. X plus y over y. Don't cancel y and y. Many times I see this. No, 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 no. The only time you can cancel is, no, wrong. The only time you can cancel is when you have multiplication between them. When you see y in each term and you can bring it out. Look at here. You have multiple between x multiplication. You have product. You have product between them and also it's in division, top and bottom. You can cancel. Okay? See, you have x multiple bracket divided by xy. In this case, I can cancel, but not in that case. In that case, y is here, but y is not here. I cannot bring y out. See, I say I cannot bring y out. So means if I can bring one out, then I have y multiple bracket divided by y. Then I am able to cancel when I have multiplication and division between them. Not in this case. So no, 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 no. Okay? I emphasize because I see these mistakes. Okay, so how about this one? Okay, so this is x squared plus y cubed divided by xy. Can I cancel anything from top? Can I factor anything from top? Can I cancel anything from top and bottom? No, because I cannot see anything to factor. I have nothing in common. Nothing is in common, so I stop here. I cannot factor anything from top. And the denominator, I'm lucky because it's just monomial. It's just one term. So it's already in multiplication. It's already. So I have to change. Remember, when I have several terms and I want to cancel top and bottom, and I have several terms, I need to change them to, instead of just addition, subtraction, I need to change them to multiplication. So means I have to bring something out, and and that thing has to be in common with all of them. Okay? Otherwise, I'm not able to do that. The denominator is in multiplication xy. I'm lucky because it's just one term, monomial. But the top, no, I have plus. So I have to be able to make it like multiplication. So it means I have to find something in common and bring it out. I'm not able to do that. How about here? How about this? Okay, so it is 2x squared plus 4xyz over 2x cubed this. Do I see anything common? Yes, I see 2. I see x, right? For bottom, no, oh, bottom, I'm lucky because I have one term there, just monomial. So 2x I factor, x plus 2yz, right? Now can I cancel? Yes. So I can say 2x times x plus 2yz. I can show you just all the steps. So this 1, 2yz. So divided by 2x, x squared z. And can I cancel? Yes, 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 and yes. And what is left? So it's x plus 2yz over x squared z. Okay? So I have several terms top. I have a monomial bottom. For monomial, I'm fine. It's in multiplication form. For the top that I have plus and minus, I have to find something in common. I have to factor it, and then I am able to cancel. Not before that I see plus minus. Or distribution. Monomial multiple by a polynomial. So what should we do? Okay, you multiple one by one. So a number, variable, expression in front of a bracket can be distributed over the bracket by multiplying in each term. So you have to multiply by each term. Okay? It says like a rainbow. So you multiply with this and you multiply with this. Okay? So it is 2x plus 2y. Done. How about this one? It is xx plus xy, which is x squared plus xy. Okay? How about this? It is 2x plus 2xy minus 2x times minus 3y squared. Okay? So I can do step by step. Right? So here I'm showing you a step by step, so you don't really need to show me that part. But 2x squared plus 2xy minus 1 plus, so minus 6xy squared. Yes, that's good. I accept. How about here? Bedmass. Bedmass. I can follow bedmass. Okay, inside the bracket. Can I simplify inside the bracket? No. Can I simplify it inside this bracket? No. 3y and 4, they are not like each other. Remember, don't say 3y minus 4 is minus y or is minus 1. No, they are not like each other. They have to be like each other. Okay? So inside the bracket, I can't do anything. Inside the second bracket, I can't do anything. I cannot simplify. They are not like each other. One of them x, one of them 3y, one of them xy. Okay? See, one of them this, one of them this, one of them this, and again this one, and again this one. They are not like each other. Okay, so I can't. So what should I do then? Okay, so I do this first, I do this next, bedmass, multiplication, and then this. Okay, so equal 4x plus 12y. Remember, you multiply with each term inside. Minus 4xy minus 3xy plus 4x. Why plus? Because I have minus minus. Okay? I have to multiply minus x with each. And see, I am doing it step by step. Otherwise, even me, after so many years of doing math, I get confused and I miss one of them. And you catch my mistake. Okay? So, equal. Now, I group them. Okay, so this one, so maybe I start from this card. Okay, this one and this one. The next. This one. The next. This one and this one. Okay, so equal. 4x and 4x, 8x. 12y. Just alone, so I maybe make it, yeah, 12y. the other one, minus 4xy. So maybe I just change this to green. Yeah, yeah, it's good. So here I do, okay, so minus 7xy, these together. Okay, so I stop here, and okay, so maybe, okay, and then I continue. Okay, so I continue after.